Recalling the definitions of the sine and cosine of an angle on a unit circle, or a circle of radius r in this case. That's a bad looking r, but it's an r. On a circle of radius r, the sine theta is y over r, cosine is x over r, x over the radius. We define the tangent to be y over x, the opposite over the adjacent from this angle. The tangent function can be seen as the opposite side over the adjacent side if you have a right triangle, this being implicitly a right angle here. The sine of the angle will be the opposite side over the hypotenuse, the cosine the adjacent side over the hypotenuse. Again here, opposite side over hypotenuse, adjacent side over hypotenuse for the sine and the cosine. And the tangent is the opposite over the hypotenuse, which is, turns out, the same as the sine of the angle over the cosine. We divide opposite over hypotenuse by adjacent over hypotenuse. We're going to multiply this by the reciprocal of this. The hypotenuse will divide out. We have opposite over adjacent. And that's sine theta over cosine theta. The sine and cosine functions are very convenient, very handy for a lot of different situations. Let's say that we have this situation where we, similar to the one that we solved just a few minutes ago. If this is a 70-foot tree and a 240-foot string to the tree, then what's this angle down here? Maybe we don't care about this distance, we just want this angle. How do we find this angle? Well, we write the fact that the side opposite the angle, the 70 feet, divided by the hypotenuse, 240 feet, is the opposite over hypotenuse, which is the sine, so that the angle is the inverse sine of 270, or 70 over 240. And of course, that's easily calculated. Another situation, let's say that we climb 3 miles up a 3-degree incline. And a lot of highways are built on inclines up to about 3 degrees. That's a fairly steep road, actually. Now that's one of those roads where the trucks really slow down, and even cars without a lot of power slow down. If you travel 3 miles up a fairly steep road, fairly steep interstate, let's say, then what is the change in your altitude, which we'll call delta H? Well, delta H over 3 miles is a sine of 3 degrees. Delta H is opposite 3 degrees. 3 miles is a hypotenuse, so this is the opposite side over the hypotenuse, which is the sine of 3 degrees. And we conclude that delta H is then multiplying both sides by 3 miles. 3 miles times the sine of 3 degrees, excuse the cross out there, or 0.15 miles. Delta H then is approximately 0.15 miles. Another example. And again, you should be doing these examples without really looking at the solutions and then comparing your work with the solutions. You'll learn much more that way. If we climb 500 feet at a 14-degree angle, let's say climbing in a plane, taking a steep ascent up 500 feet, how far do we have to travel before we're 500 feet high so that we can clear that 500-foot tower? Again, writing the definition of the sine function, the sine of this angle is the opposite side over the hypotenuse. Sine 14 degrees is 500 feet over x. Multiply both sides by x, divide both sides by sine 14 degrees. We see x is 2,000 feet. So we have to travel 2,000 feet at a 14-degree incline in order to attain a height of 500 feet